Welcome to Physics World Online College, where we explain physics and make it very plain, simple to comprehend. In our class of today, we will continue on the topic motion under gravity. Today, we will consider things for a body moving under gravity. Statements of fact concerning motion under gravity. Before we continue, please remember to click on the notification bell so that you will be noticed as soon as a class video is dropped. Also remember to share with your friends so that they will know that something good, something great is happening on this channel. Let's continue. We'll recap. In the last class, we were made to understand that if you have two masses, a heavy load, e.g. a stone, and a light load, e.g. a piece of paper or a feather, and you take both objects to the top of a mountain, the top of a cliff, a height, and then you release both objects simultaneously from that height. We're made to understand that both bodies will fall down at the same time with the same rate and the same constant acceleration. Because of that, they both will reach the ground at the same time, irrespective of their masses, on the condition that air resistance or air friction is neglected. On that base, we want to consider a body under gravity. We will consider two aspects of the motion. When the object is going up, vertically upward, we will call it upward motion. And then when the object gets to the highest height, highest point, momentarily, temporarily, and then it starts coming down. And when it's coming down from that height, we will refer to it as the downward motion. So let's look at it this way. Let's say the body is thrown up with an initial velocity of u, 80 meters per second. So we throw it with an initial velocity of 80 meters per second. This is the velocity of throw, vertically upward. Now, as this body is moving up, because it is going against gravity, the acceleration of that body is negative g, it's minus g. So we say the body is retarding as it's going up, meaning the velocity of this body will be reducing from 80 to 70 to 50, 20, and then gets to 0 at this maximum height. At this highest height, the final velocity of the body for the upward motion will be equal to 0. So this is the upward motion. This is the highest height or highest point or maximum height. Once again, when you throw the body up with a certain velocity, say 80 meters per second, the acceleration of that body is minus g, meaning the body is retarding, is decelerating, the velocity is reducing. until it will reduce to what? 0 at the highest height, at the highest point, at the maximum height. So you must take note of that statement. At the maximum height for the upward motion, for a body that is thrown vertically upward, the final velocity is 0. This is the upward motion. Then for the downward motion, when the body is released from a height and is coming down, falling down under gravity, take note, at this maximum height, the initial velocity is 0, because we assume that the body is coming from rest. That we can liken to a mango fruit that is suspended on the tree. It's at rest. So when it is ripened, it falls. So it is falling from that height and is falling from rest. So the initial velocity at the maximum height is 0. Then as the body is coming down, it is moving in line with gravity, which means the acceleration A is equal to plus G. So we use minus G when the body is going up, and we use plus G when the body is falling down. So we are saying that the velocity of that body released from a height, released from the top of a mountain, increases from 0 to 10 to 20, 50, 70, and becomes maximum. That is, that 80 meters per second we use here, it will be maximum before it hits the ground. Again, take note of that. So the point I'm making is this: for the downward motion, for a body that is released from a height, the initial velocity at the maximum height is 0. The body is moving in line with gravity, so the acceleration is positive. Also, the body will attain a maximum velocity before hitting the ground, given as what? Vmax. We will tell you in the equation is also can be obtained using square root of 2gh, or g times time. So there are things we will be asked to calculate for this body that is undergoing this motion. What are the things? For the upward motion, let me put it into two parts. For the upward motion, we will be asked to look at for the time it takes the object to go up. Time taken to go up. Let's call it T1 or T up. We will determine it later. We can also be asked to find the total time. The total time is capital T, and that is equal to 2T1. The total time, we will also call it the time of flight. So once we are giving for the body that is going up, once we know the time it takes to get up, we multiply it by 2. We will get the total time. That total time actually means the time taken for the body to go up, and then for the time taken for the body to what? From the top, reach the ground. So time taken to go up is equal to the time taken to what? From the top, get to the ground. So also, we will be asked to look for the maximum height attained. We will call that H max. We will be asked to look for it as well. So this maximum height attained when the object is thrown vertically upward, we will obtain a formula for obtaining the maximum height. Also, we will be asked to look for the range. The range is also called the horizontal distance. Is given by this portion, range or horizontal distance. To obtain it, we multiply it the initial velocity times the time it takes to get up. So we will obtain relationship or formula for these various points. Likewise, we will be asked to calculate for the downward motion the time it takes for the object to get down. We can call it T2 or T down. Once we know the time it takes for the object to from the top gets to the down, we can get the total time, which will be capital T equals 2T2 or 2T down. Likewise, we can either be given the maximum height from which the body is released, from which the body is dropped, or we'll be asked to calculate it. Of course, we will obtain the relationship, the formula for obtaining the maximum height. Likewise, we can be asked to obtain the range or horizontal distance for this body. And for us to obtain the range, we will use R equals U times T2. Now, this velocity here, I will tell you more about it. This velocity we use to multiply this time it takes to get down. It is not the same thing as this velocity we have said is what? Is zero. I will explain it in the next class when we begin to talk about horizontal projection. Now, also, we will be asked to find the maximum velocity before the body hits the ground. And I've told you that maximum velocity, we can obtain it with square root of 2gh or gt. So these points are very important for a body that is undergoing motion under gravity. So the points are there for you to understand. So we can obtain 4 equations similar to the 4 equations we obtained before for uniformly accelerated motion. We can obtain 4 equations of motion under gravity. What do we have to do? We will replace wherever we have x, that is distance or displacement, in the uniformly accelerated motion, we will replace it with h in motion under gravity. Also, where we have acceleration a for uniformly accelerated motion, we will replace it with plus or minus g for motion under gravity. So we can get 4 equations of motion under gravity. Let's obtain them. Remember, the first equation of motion for uniformly accelerated motions is v is equal to u plus at. I'm mimicking it now. To obtain the motion under gravity, the first equation becomes v equals u. Where I have plus, I will put plus or minus. Where I have a, I will put g times the time t. So when you are told that the body is thrown vertically upward, you will use minus. So it will be v equals u minus gt. Then when you are told that the body is released from a height or falling from a height, then you will use v equals u plus gt. So that's the way it is applied. The second equation becomes x equals ut plus half at squared. Wherever we have x, we replace it with h. That is the height. giving us ut, where we have a, I will put g, where we have plus, I'll put plus minus half gt squared. Once again, you will use minus when the object is thrown vertically upward. You will use plus when the object is falling down. The third equation of motion is v squared equals u squared plus 2as. For motion under gravity, the equation will now be v squared is equals to u squared plus minus 2gh. Plus and minus interpretation implied. The fourth equation says S is equals half open bracket u plus v close a bracket times time t, which will become h in place of x is equal to half open bracket u plus v close bracket multiplied by t. So anytime you are asked to state the equations of motion under gravity, these are the four equations. Similar to these four equations, like I said, only you replace x with h and replace the plus with plus and minus. Plus when the body is falling down, minus when the body is thrown up, is going vertically upward. Then a is replaced with what? G. So we have obtained the four equations of motion under gravity. And let me warn you, if you are asked to state the equations of motion under gravity and you state this one, they will not give you the mark. So this is the preferred once it reads equations of motion under gravity. So these points you see for the upward motion. Let me recap. For the upward motion, or the motion of an object projected or thrown upward, the acceleration a is minus g. I said the body is retarding or decelerating, so the velocity of that body is reducing. From 80 it will reduce until it becomes 0 at the maximum height. 2. When projecting object vertically upwards, at that maximum height, the final velocity is 0. So this statement, v equals 0 at maximum height, is very important. You take note of it. When we are obtaining the formula for each of these half equations, we will use it. Also, we said at the maximum height, h max, the object is said to be momentarily at rest. So when the body retards and the velocity decreases and gets to 0, it will rest temporarily, and then before it will start coming down. Then for the downward motion, or the motion of an object release or drop from a height or tower, like I explained earlier, it means the body is already at the top, just like any of the fruits. The mango fruit, the coconut fruit is already suspended on the tree at the top. So it's at rest there. Good. So for a body that is already at the top, if the body is what? Is released, is dropped, is the acceleration will be plus g. Why? It is moving in line with the force of gravity. It is moving in line with the acceleration due to gravity, unlike this one that is opposing gravity. So its velocity is reducing. Here is in line with gravity. The velocity is what? Increasing. Beginning from 0, it increases till it becomes maximum before hitting the ground. Take note. Also, if a body is released or dropped or thrown from rest, I've explained that from the top of a tower, a cliff, or a height, Then at the maximum height, the initial velocity is 0 because the body is what? From rest. The initial velocity is what? 0 for the downward motion at the maximum height. And lastly, the object will have a maximum velocity before it hits the ground. Emphasis on before hitting the ground, because once the body hits the ground and comes to rest, and we said before, whenever a body comes to rest, its final velocity will be what? 0. So this velocity peak, this velocity becomes maximum only before the body hits the ground. And to obtain that velocity, we will use V max equals square root of 2gh, or g times t. T then being the time it takes for the body to what? Reach the ground. So these are the points you need to know. In our next class, I will use these points and obtain the formula, half formula for this body that is going up, and another half formula for the body that is up coming down. Take note of the points. Thanks for listening. Bye.